What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button, and make sure you watch all the way through. There's a lot of good stuff coming. Let's get to it.
There are many different types of such regulators in automobiles. They are also found on heavy trucks, where compressed air is used to operate the brakes. But we will talk about the one that is relevant to passenger cars and distributes brake fluid between the axles. New brakes, new problems. The hydraulic brake system was first used on Malcolm Lockheed's car in 1917. Within a few years he made a number of significant changes and by 1925 had already received 7 patents for his inventions. However, the rawhide cuffs quickly dried out and started leaking brake fluid. In 1923, engineers of Maxwell Motor Corporation finalized the system by using chemically resistant rubber for manufacturing the cuffs. Since that time, the hydraulic brake system has been widely used in automobiles. In the 1940s it reached a new stage of development. Motors became more and more powerful, transmission, suspension and other units allowed to provide high comfortable speed. However, the brakes sometimes could not cope with their work when it was necessary to stop the car urgently only from the force of the pedal pressed by the driver. Therefore, different types of amplifiers were massively introduced into the braking system, vacuum and hydro-vacuum, which worked due to vacuum in the intake manifold, as well as hydraulic, the work of which was provided by a pump. Yes, cars began to stop faster, even if they were accelerated to a high speed, but their new disadvantage became apparent: front and rear brakes were not quite simultaneously applied, and then there was a danger of losing control of the car. In more efficient systems with disc brakes on both axles, this became particularly acute. Vacuum brake booster first appeared on the Pierce Arrow in 1928. But due to its complexity, as well as the great conservatism of car manufacturers, even in the 30s some of them considered mechanical braking system better than hydraulic. Such devices were not widely used. In the 1950s, in order to improve safety in the event of a leak in the brake system, separate circuits began to be used. Usually the diagonal principle was used, which has survived to the present day, but sometimes a front-rear axle split was also used. This somewhat complicated the device of braking system, but significantly increased the level of safety. How the caliper works. About the same 50s on cars began to appear, and the regulator of braking forces, RTS. Attempts to apply such devices were made earlier, but a fully working mechanism suitable for mass use appeared only by the early 60s. For the whole history of its application up to the widespread of electronic systems in the late 90s it was almost unchanged. It is interesting that at the end of its history, RTS was often neighboring with electronic systems, including ABS. This fact sometimes caused a great desire of the owner to remove it from the car so that it did not interfere with the work. At first glance, the regulator's design is not complicated. The principle of its operation is that it automatically changes the distribution of pressure in the hydraulic circuit of the braking system. Depending on the load of the vehicle, it transmits more or less force to the rear brakes. Its main task is to prevent the rear wheels from locking, which would lead to loss of control. RTS is attached directly to the body or frame in the area of the rear axle and is connected to it by a powerful spring, coiled or torsion. It turns out that depending on the load of the car itself, the valves in the regulator open more or less, and therefore, when you press the pedal to the rear brakes transmitted more or less pressure. Inside, however, the RTS is not so simple. The force from the spring does not directly affect the operation of the valves, only the load on the spring is taken into account, not the road conditions. The regulator volume is divided into 2 chambers, one of which is connected to the brake master cylinder and the second with the rear wheel slave cylinders. At rest, the fluid pressure in them is the same, but in the first one it acts on a smaller area of the piston and in the second one on a larger area. When the pressure in the circuit occurs, the piston tends to move to the side of less resistance, but this is counteracted by an internal spring. Its stiffness is selected so that the pressure in the regulator is equalized when the external spring is unloaded. As soon as the driver presses the brake pedal, the pressure from the master cylinder overcomes the force of the internal spring. The piston moves and the valves reduce the passage of fluid to the rear brakes. This prevents the rear wheels from locking. The path for the brake fluid is maximized when the rear of the vehicle is fully loaded, that is, the distance between the body and the suspension member to which the PTC is attached is minimal. It is in this situation that the not-so-effective rear brakes work as productively as possible, as the risk of the rear axle drifting during braking is minimized. In the case when the main weight is located in the front, for example, the car is only occupied by the driver without passengers and luggage, the rear brakes are affected by a minimum amount of fluid, there is almost no force on them, and skidding of the unloaded rear part of the car due to locking of the rear wheels is almost impossible. By the way, the mechanical brake force regulator has not completely disappeared today. It is still used on sports cars for racing, but it has a slightly different design than the one used on civilian cars. It is installed in the cabin and its adjustment is carried out by the driver just before the competition, depending on the conditions of the track and weather conditions. But this, as they say, is a completely different story. Magic problems in braking. In order for the brake force regulator to work properly, it is necessary to know some important points. First of all, when operating the car, it is necessary to periodically check its performance. The necessary force of the external spring is set in accordance with a special template with the subsequent check of uniformity of braking of front and rear wheels on the stand. It is not allowed to put the necessary gap by eye, as well as bend or compress the external spring. You can preliminarily check the correct operation of the regulator on an ordinary road. The main thing is to make sure that the road surface allows leaving wheel marks when braking. To do this, accelerate to a low speed, 40 to 50 km per hour, and then brake sharply and intensively. By traces on the road you can determine how evenly the brakes of the front and rear axle work. If the rear wheels lock up too early, the PTC is fully open, and if their braking is delayed, it is almost empty of brake fluid. In both cases, the mechanism should be correctly adjusted or replaced. Some owners of old cars, in case of any malfunctions of the rear brakes, there is an irresistible desire to first remove the RTS from the system. However, this should not be done categorically. And not only because it is a direct violation of the rules of vehicle operation, making changes to the design, which prohibits the operation of the vehicle. The most dangerous variant of attempts to improve the operation of the brake system is to completely eliminate the regulator from operation. In this case, it is not necessarily removed, sometimes it is simply cleaned out. It is not safe to do this even on cars with ABS, as it was calculated exactly for work with RTS. If it is not, the ABS unit can incorrectly distribute forces on the brakes and reduce the pressure in some of the calipers to avoid too late blocking the wheel. The best way to maintain the performance of the brake system is banal, regular maintenance of all its components, including timely replacement of the brake fluid, usually every 2 years. It is this simple procedure will help to avoid the negative impact of wear products and moisture, which inevitably accumulate in the brake fluid. And it is in the brake force regulator that its negative effects are particularly pronounced. And one more important point, the fans of tuning should not forget about the brake force regulator and the peculiarities of its work. Any change in the suspension, installation of spacers, stiffer or too short springs, leads to the fact that its settings are disrupted. As a result, it can either completely stop working or depressurize the rear axle hydraulics too early, significantly increasing braking distances. In conclusion, the exploration of black and white magic reveals the fascinating duality of sorcery, where intention and morality shape the practice. Whether it's the mystical arts of a sorcerer or the precise engineering of a mechanical brake force regulator, both embody the power to influence outcomes in their respective realms. Understanding these concepts not only enriches our appreciation for the complexities of magic and technology but also encourages us to reflect on the ethical implications of our choices. As we navigate through these intriguing subjects, let us remain mindful of the balance between light and dark, both in magic and in life. Thank you for joining us on this journey.